I write everything on board here. This topic is on functional group, right? First, functional group I write. Functional group. You probably know the meaning of the group. Okay, simple. Group is not single, right? Is it single? No, single and group are different. Group means maybe more than one together, right? More than one together we call group. Easy and finished. Here are more than one means more than one atoms. Okay, more than one atom. Suppose a carbon atom and oxygen atom. Two atoms together is a group. Suppose an oxygen atom and with another hydrogen atom is a group. Okay, maybe two or many is a group. Okay, and functional. Functional means this also has a meaning. I mean, we know probably function. You know meaning of the word. If this is a verb, function. I write with this marker on board, but when the ink finished, then I cannot write, right? And what I can say in terms of function. The marker is not functioning anymore. Understand? So this is not working. Function means work or react. Here in chemistry, when I talk about functional or a function, then this must be reaction. Okay? We have many functions. The marker has a function, just to write, nothing else. It cannot do anything else. Just do one thing, is write. And when I say functional group, that's a chemical substance that's going to function, just can do one thing. What is that? React. Okay? So here function means what? React. A compound functions, which means a compound reacts. We already know that hydrochloric acid reacts with many things. It can react with metal to give hydrogen gas and salt. It can react with carbonate to give carbon dioxide. It can react with base to give. So it's a react. I say that can I say function. Okay. When we'll study organic chemistry, this function means this. Everybody clear? So functional group means a group that reacts. Okay, a group that reacts, and this group is of a compound. This group is of a compound, means that you may have a small compound, small in size, or big compound. Okay, small compound or big compound. In most cases, when the compound reacts, then only a small part of the compound reacts. Do you understand what I say? In most cases, when the compound reacts, only a small part of the compound reacts. I show you an example. Suppose this is a compound. I write big compound, CS3, CS2 here, CS2, 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 and here I write OH. Okay, look at this. This is compound OH. And you know this is a big compound, right? And some compounds are much bigger than this. In organic chemistry, we'll get much bigger than this. But it is very simple. Don't worry. Okay, this is compound. And if this reacts, if this compound reacts, with many things it reacts. Only this part will react. Understand? Only this part will react. And after the reaction, this part will change. And how about this part? Will remain unchanged, will remain same. I show you when this reacts with a certain reactant. I don't want to show now. If this reacts with certain substance, you will get here. I write CS3, CS2, CS2, CS2. How many? 1, 2, 3, 4, 5. 1, 2, 3, 4. And I write. Okay. So this is the reaction. Look at the change. Change happens to the last group only. Okay. This is here reactant. This molecule is going to react, and after the reaction you get the product. And compare the reactant and product. This part same, unchanged. Just last part got changed. Understand? So only this part has functioned or reacted. And I can show another CH3, CH2, 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 1, 2, 3, 4, probably another, right? Yes. Cl, chlorine. Look, chlorine. Instead of OH, I have written there Cl. Okay, this is a reaction. I mean, this is a product of a reaction. This has reacted with some reactant and has given the product. This, and many others. And many others. There are many other reactions depending on which is the reagent. Reagent means the other substance this reacts with. Again, I say reagent means the other substance. This cannot react alone. Something must be added. What is the something? It's called reagent. I mean, other reactant. Okay, this is a common question I get from the students. What the reagent mean? Reagent means the other reactant. So when this reacts, giving the products, and in the products you see most part of the molecule is same, unchanged. Only a small part is changed. That small part is functioning, reacting. So we call that functional group. Are you clear? What's functional group now? Functional group means, what is that now? What's now we say it's a group of atoms. I write here, right here, a group of, because this is a group. Group of what? Group of atoms. Okay, one part is finished. Which reacts with other substances, right? So as this is for only organic chemistry, I can add a group of atoms in an organic molecule. I add this because this is we just get this only in organic molecules, only in organic compounds. For hydrochloric acid, we don't say that functional group, because hydrochloric acid or inorganic base acid, many other reactants react. The complete compound reacts. The whole compound reacts. This happens only for organic compounds. The big molecules, only a small part reacts. So I add there a group of atoms in an organic molecule, okay, which is responsible. Okay, I can write responsible for the chemical. Chemical means reaction, right? Chemical properties. Of the compound or of the molecule. Are you clear? Are you clear? You may not have to define in exam. I don't get the questions in exam that define functional group. This is a group. Use the common sense and try to understand. That's enough. That's enough. It's a group, okay, group of atoms, and this group reacts. Only this group reacts, not the other part of the compound reacts. Finished. And if we need to define completely this, so then we can write the statement. Clear, everybody? Finished? Do you have any questions?
Yes, sir.
Okay. There is a reaction. Which doesn't depend on the functional group. It's called combustion. And only one reaction is there, not the reaction of functional group. Other than one type of reaction, which is combustion. If you burn this out, most of the organic compounds are flammable. You know what's the meaning of flammable? You can burn out. Okay, like petrol, you can burn out. And if you burn out any organic compound with any functional group, there are many functional groups, any functional group you burn out, then you will get carbon dioxide and water. Here carbons, right? Here carbons, organic compounds must have carbon. Must have carbon. And that carbon will form carbon dioxide. So that was the question someone asked me, that methanol, right? The combustion of methanol, right? That was the question someone asked me. So methanol means an organic compound that contains carbon. So the product will be carbon dioxide. Okay, product will be carbon dioxide. And and hydrogen also there. Hydrogen also there. When hydrogen burns, that will give water. So these two are products, carbon dioxide and water. Okay, and this type of reaction, I say combustion, is not a reaction of functional group. That's a reaction of whole compound. But except this type, I mean combustion, all other reactions in organic chemistry, only by the functional group. Everybody clear? Only by the functional groups. So we have different functional groups. We have various functional groups. Suppose I write here OH. OH is a functional group. Remember, you already know one OH, which is OH ion, alkali, potassium hydroxide, sodium hydroxide, you know, right? Sodium hydroxide, potassium hydroxide, you already know. But these hydroxides, metal hydroxides are different. They are not functional group. We are talking about when carbon bonds with OH. I mean in organic molecules. So we are studying here organic chemistry. In all the organic chemistry, there is carbon, and this OH is bonded to carbon covalently. Here is no OH ion. So are you clear? Do you have any problem with OH? OH is metal OH, sodium hydroxide, potassium hydroxide. That is not there. Okay, if OH is there, which is bonded to carbon, must be carbon. This is a functional group. Okay, another function, some other functional group we get. This is a functional group. This is a functional group. They have different names too. Yes, and then you get here CHO, a functional group. Then you get here COOH. COOH is a functional group. And there's some more I'm going to show you all together. So OH means alcohol. Alcohol. I mean, the compounds which have OH, the compounds are called alcohol. The compounds are known as alcohol. So last day in our last class, we classified organic compounds as saturated and unsaturated, depending on how many bonds there are between carbon atoms. And today we're going to classify again the organic compounds depending on functional groups. Okay, the compounds which have OH, there may be many compounds. There may be hundreds of compounds, different compounds with OH. All the compounds have a general name. What is that? What is that?
Sir,
all the compounds have a general name. This is alcohol. Understand now? What I say again? Again, I repeat. If you get hundreds of compounds, every of them contain OH as functional group. Okay, so they're together. They're together same type because they have OH, same type. So all the compounds have a general name. What is that? What is the general name? Alcohols. Clear? Are you clear?
alcohol.
So that's there, alcohol. And then if you get compound with carbon-carbon double bond, there may be many compounds, hundreds, thousands of compounds with carbon-carbon double bond. Okay, and they are in different group, not like alcohol. Okay, they are not alcohol. So what they are? We say alkene. I say alkene. Don't worry about the names if you don't know. Okay, alkene. So there could be so many compounds. There could be so many compounds with this functional group, and all the compounds have a general name. What is that? Alkene. This is general name. Excuse me. Every of the compounds have a particular name. Like you are all students. Students is a general name. So here are many compounds with which the general name is alcohol. Here again many compounds with carbon-carbon double bond. General name is alkene. Okay, but they also have individual name. We'll learn them later. So this is, what is that? It's aldehyde. It's aldehyde. Aldehyde. This is carboxylic acid.
স্যার অ্যালডিহাইডটা দেখা যাচ্ছে না।
This is here carboxylic acid. Carboxylic acid, and some more are there. I'm going to show them. So now one more thing. Functional group is gone. Functional group is gone. Okay. Functional groups means, again I repeat, the small group, this is a group of atoms which react with other substances, other reactions. That's functional group. Functional groups are many, and we're gonna have 8 to 10 functional groups. There are many. Basically, we'll study here only few, but we'll see some more functional groups. Okay, and I have introduced you another thing. This is a group of compounds. What's the alcohol we say? Group of compounds. Are you okay? Group of compounds. There are many compounds. All of them are similar. How are they similar? They all have OH. And here I say alkene. Here again many compounds. All the compounds are similar because all of them have this. Okay, there are many compounds and many compounds. Again, there's this, and again so many. Okay, so we use another term to explain this, to describe this, which is a homologous series. What do you say? Homologous. Homologous series. Homologous series. Homologous means similar. Okay, homologous means homogeneous. Homologous means homogeneous, which means similar. Do you have any problem with the word homologous series? So this is a homologous series. I already mentioned that this is a group of many compounds with OH, many compounds with OH, as they all have the same thing, same functional group OH. We have called them a general name. What is that? Alcohol. Okay, so alcohol is also known as a homologous series. A homologous series. What's this homologous series? Alcohol. Then this is another homologous series. Series means you understand many compounds, series of compounds, the series of compounds. And what do you call this series? Another homologous series. Another homologous series, which means these are different homologous series. Okay, these are different homologous series. In every of the series, there are many compounds. In every of the series, there are many compounds, but they are very similar. So how are they similar? What is the similarity you already got there? In any homologous series, I say alcohol. What's alcohol? Alcohol is a homologous series. Alkene is a homologous series. Alcohol is a homologous. Carboxylic acid is a homologous series. And the compounds there in every series, I mean every group. Series means here group. Compounds there in every series have similarities. And how are they similar? You know already one. What's that? How are the compounds in a homologous series are similar? They all have same functional group that I'm showing, but you can answer this question. They all have same functional groups. Okay, so suppose here alcohol. Alcohol is a homologous series, right? And here are many compounds, right? Suppose 1000 compounds are there, suppose. And all the compounds are similar, I say. This is why these are in a group. Okay, and how are they similar? They say they all have OH. So all the compounds have, this is common thing. Similarity means what's common. So all of them have the same thing. What's that? OH. And if they are alkenes, this is another homologous series, another type of compound, another group. We said all of them has this common. Okay. Now I test your IQ. Now if I want to know and ask you to state another similarity, the compounds in our series state another similarity other than functional group. Can you?
Last name of the compound is same. The
last part of
the compound is.
That I didn't mention yet. So up to today's discussion, today's class, I just have discussed what other way the compounds in any homologous series or in any of the groups are similar. This is one you say clearly that they all have same functional group. Alcohol, every of the compounds has OH. Okay, if alkene,
They
every of the
react with
compounds
oxygen to form carbon dioxide and water.
No, that's not a similarity. This not. No. You say no. Yes, anybody? It's IQ. I say it's IQ question because you all know, everybody know. We have discussed this today, so I'm waiting to get your response. You parna.
So they have all have L in the beginning of their name.
No, okay, you failed. Everybody failed. But I already discussed this today, to this class. What does the functional group mean? What the functional group means? The group that reacts, right? And this group, alcohol, they all have same functional group, right? In all the compounds, only OS will react, right? Okay. So don't you think the reactions should be similar? Because they have same thing to react with other substances, right? So this is there. What other similarity there? As they have same functional group, only this group reacts, so reactions will be similar. The reactions will be similar. So in alkene, if I talk about alkene, which part will react? Carbon double bond, right? Which part will react in alkene? Carbon double bond. Suppose you have two different alkene, and certainly both of them have this carbon double bond, right? And if both of them react, shouldn't the reaction be similar? Because the first compound only carbon double bond will react. Look at the second compound, only carbon double bond will react. So when you're getting different compound, but the same thing, same part, which is common part, is reacting with others, shouldn't be the reaction similar? What do you say? Similar? Must be similar, because the other part for which these molecules are different. For other parts, maybe carbon number is different. Maybe some other ways are also there to be different. But the same part, common part, is the functional group. Are you clear now? So if I ask you, state two similarities of the compounds in a homologous series. Can you write that? Two similarities of the compounds
Yes, sir.
in the homologous series. What are they are? They have same functional group. Number two,
Functional group. Same.
whenever is this this cannot be there. The students forgets the next point. If the same functional group there, reaction will be also same or similar. I don't say same reaction. I don't say. Why is not same? Because the other part is different. Other part has little influence, impact or effect on the functional group. Little. So reaction may not be exactly 100% same. Okay, suppose you know a reaction of sodium and reaction of potassium. Okay, reaction of sodium and reaction of potassium. We say the reactions are similar because when sodium reacts, how does sodium react? It loses an electron. When potassium reacts, how does it react? It loses an electron. Okay, so do you say the reactions are same? No. What do you say? The reactions are similar because potassium reacts at faster rate than sodium. Understand? And when they react, sodium will give sodium compound and potassium will give potassium compound. So now, how can be the same? So better we say similar, right? Everybody clear? Similar. So when I say they have same functional group, they must have what? Okay, I want to show some more similarities. Okay, more similarities. Here I write alkane. Here I write alkane. What is alkane? Alkane is a homologous series. Are you clear about homologous series? It's a general name of many compounds.
Yes, sir.
This is a general name of thousands of compounds. They're similar. And they are together in a group. This group is alkane. I write another alkene. I write alkene. Okay, this is another homologous series of compounds. All are similar in many ways. We already got two. Here I write alcohol. Alcohol. Okay, and we have more. And in our course, we'll just study these three mainly. So I show you another similarity. What is that? General formula. Here in chemistry, in organic chemistry, you will learn new things. But new things are easy things. Whenever you get new things, some of you are shocked. This is a problem. So these are easy things. Okay, suppose you will learn already functional group. Do you have any problem with functional group? No. No. Okay. Do you have problem now to state two similarity or similarities? Okay. No.
No, sir.
So here you get some more similarity. You learn and things become easy. I say functional. What I say? General formula. Functional group was a term. General formula is another term. I write general formula of this compound. I write Cn. N is a number. Don't worry about N is a number. It could be 1, 2, 3, 4, 5 on any value. And hydrogen is 2N. 2N. This is very simple. Be careful. This is very simple. Hydrogen and carbon. These two together. If compound made of hydrogen and carbon, what do you call them? Hydrocarbon. So this is hydrocarbon. Alkane is a hydrocarbon. Okay.
Hydrocarbons.
And how many carbon here? We don't know, right? We don't know how many carbon here because N could be any number. How many hydrogen here?
2.
Yes, that we know.
2.
That we know. I say I don't know how many carbon there. It could be any number, but I know how many hydrogen are there. What's that? Double. Excuse me. Double of carbon. If this is 1, this will be 2, right? If this is 5, this will be 10. No. Here is 2 more. To be alkane. 2 more. Now you understand how many hydrogen to be there? If I write 2 here, now say, if hydrogen is 1, carbon is 1, then how many hydrogen here you can estimate? 2 into 1. Look, 2 into 1, what do you get? 2 into 1, 2, and plus 2, 4. So if hydrogen is 1, then carbon is 1, hydrogen will be 4. Clear? Now, if carbon is 5, then how many hydrogen to be there? 5 into 2, 10, plus 2,
2 into 5.
12. So
Plus
the
2.
hydrogen, excuse me, hydrogen number is 2 more than the double of carbon number. Double number of carbon plus 2. That's the hydrogen number. Okay. So if you get a question, how many hydrogen atoms in an alkane? This is alkane, right? If you get a question, how many hydrogen atoms there in an alkane with 10 carbon atoms? Can you answer this question? What is that? How many hydrogen atoms in an alkane with 10 carbon atoms? What is that? 22, right? Everybody knows this? Because if this is 10, how many hydrogen were 10 into 2?
Then 2 into
It's
10 plus
20,
2.
and again 2. Very simple. Okay, questions are like this, you will get. So now alkene, this is called general formula. Excuse me, this is called general formula. I'm going to explain this again more in details. Come on, alkene. For alkene, this is even easier because the hydrogen number, and this is also hydrocarbon, made of carbon and hydrogen alone. But carbon is N, hydrogen will be just double. Finished. The number of hydrogen will be just double than number of carbon atoms. Are you clear? Everybody, carbon number, hydrogen number will be double than the number of carbon. Finished. Isn't this easier? This is general formula. Are these two same? This general formula same? No. Here two?
No,
Yes,
sir.
no two. Now get alcohol. Alcohol, I write. Cn. This could be any number. Don't worry about the number. This could be any of 5, 2, 1, 3, 8, any number. Here is ACE. ACE number is again double. Okay, double than this. Like this you got that, like this you got that. But here was 2 more, and here is 1 more. Here is 1 more. Is there any problem to understand this? If carbon is 5, then how many hydrogen to be there? 11, okay? 5 to the 10 and 11,
11.
okay? If carbon is here 3, then how many hydrogen to be there? What's that? 7. If carbon is there 100, how many hydrogen there? 201. Easy, right?
201.
And this is not enough. Alcohol, here is all, its functional group is OH. Here is an OH. So this is together with OH added. Together, this is general formula of alcohol. Okay, so this is alkane, this is alkene, and this is what? Alcohol. These are three what? General formula of 3 homologous series. In this series, again, I say there are many compounds. In this series, there are many compounds. In this series, there are many compounds. I'm going to show some compounds. Like, look. The first.
এখানে যদি দেয়া থাকতো কার্বন 10 হাইড্রোজেন n তাহলে কি করতাম?
Carbon 10, hydrogen. Sorry, repeat again.
স্যার এখানে যদি আমাদের হাইড্রোজেনেরটা না বের করতে হতো আমরা যদি কার্বনেরটা বের করতাম
Oh
তাহলে
yes,
কি হবে?
that's also easy. That's also easy. You can do this. She asked me if I was asking you if carbon is 5, how many hydrogen there, right? That was the question I asked you. This is double 5 into 2, 10 and 2. What's that? 12. If you get a question, yes, this could also be question. If there's a question in an alkane, hydrogen is 12. How many carbon there? So divide this with 2 and no, first subtract 2. Okay, 12 minus 2. Yes, 12 minus 2, right? And then divide with 2. Okay, understand? So look, we don't have
Yes,
that much
sir.
time. Great. So I'm going to show you some examples. I'm giving some examples. Alkane. If the first member, for the first member, if here n equals 1, then this will be C, right? 1. N equals 1, its value is 1. And how many hydrogen to be there? 4. Then C is 4. This is the first member of this group. So you may also have a question. I got this question in O-level exam. What is the first member of alkane? This is the methane. This is the name. You will learn this later in the next day. This is called methane. This is the first member of methane. We use this for our cooking gas. Okay, cooking gas. This is mainly this there. Cooking gas. If the value is 2, n equals 2. So what's the value for H? What is that? What is that? 6. If the value here 3, what's the hydrogen here? 8. If the value is 4, how many hydrogen there? 10. So this is how you can put different values, various values to get various compounds. These are different compounds. I told you there may be thousands of compounds with different values of n. Okay, clear? But all of them are alkane. And one thing interesting, we have classified this compounds into different homologous series. I told there that we have classified the compounds depending on what? Depending on
Homologous pair.
functional groups. Depending on functional group, we have classified these compounds. Here are 3 homologous series. We have more homologous series, and here only 3. When OH is there, we call alcohol. When carbon-carbon double bond is there, we call them alkene. And this is ane. Ane means in this group there is no functional group. Understand? Only this is a group, or this is a homologous series. The compounds. This is on recording again. Okay, now look at this alkene. You can put various values of n to estimate, to derive different formula of the compounds. Suppose here you get n equals 1. If n equals 1, what do you expect to get? C is 2, right? And if n equals 2, C2 is 4. If n equals 3,
4.
C2 is 6. Just look at double. If 5, if 4, this will be 8. If here is
8.
5, this will be 10, right? Everybody clear? So here are few things to be added. Here in alkene, there must be a carbon-carbon double bond, right? To be an alkene. This is the functional group. we haven't shown any of the functional group because we're writing the molecular formula. Probably you know what is molecular formula, right? Molecular formula is just shows how many atoms there. Okay, doesn't show the structure. Molecular formula. So here you don't see carbon-carbon double bond. Later we'll show in the displayed formula their functional groups. Just know there are every of the compound has this. Okay, must be there. Otherwise, they cannot be alkene because the functional group to be an alkene must be there. Okay, everybody clear? So now I'll just ask you one thing. Which of the compounds I've given here cannot have this? It's not possible to have carbon-carbon double bond. Which one?
CH2.
Yeah, CH2, right? Can a carbon have carbon-carbon double bond alone? If this is one carbon, is this possible to have carbon-carbon double bond? So
No,
this is
sir.
not there. Excuse me, this is not there. This is not the first member. This first member starts with 2 carbon atoms. Everybody clear? For alkane, the first member starts with 1 carbon atom. Because here is no functional group, here no carbon-carbon double bond. But as all of them must have carbon-carbon double bond, so that must start with at least 2 carbon atoms that we get here. So this is not there. So if you get question, write the formula of first member of alkene. Can you write the first member? If you need to write the first member of alkene, can you write the formula? This is here. Second member, can you write the second member? Second member of alkene. Okay, some of you will mistake, right? Second member, some of you will mistake because you may write this is a second member. Is this second member? No, this is first member. Okay, got this? Okay, now last. Alcohol, put different values of N. If N equals 1, what do you get? C, H, then what's double of 1? 2. 2 plus 1? 3.
3.
This is the first member of alcohol. Okay, everybody? First member of alcohol. If the value is 2, what do you get? C2H, 5 ways. If the value is 3, C2H, 7 ways. If the value is 4, what do you get? 9 ways. Okay, I already discussed 2 similarities of these compounds. 2 similarities. What are the similarities I already mentioned? They all have same functional group, and here none of them has functional group. That's also similarity, and they all have double bond functional group. Okay, and another similarity you got there, all have similar reactions. Okay, similar reaction. I want to show here just one more similarity, one or two. Okay, 2 more similarity. The first one is, what's the difference between 2 adjacent member? Do you understand what I say adjacent? Adjacent member, understand? Adjacent, close member. So what's the difference between these 2 adjacent member? What do you get here? How many carbon here? 2. Here's 1. So 1 is C, right? 1 difference in carbon number is C, 1. And how many hydrogen here more? 2. So isn't this CH2? Right? CH2. So how these 2 are different? These 2 are again adjacent. How these 2 are different? 1 more carbon and how many hydrogen? 2. So here we get CH2, right? And how these 2 are different? 1 more carbon and 2 hydrogen atom. CH2 again, right? This
2
is
hydrogen atoms.
This is not only here. For any of the homologous series between 2 adjacent members, the difference is what? What do you get here? What do you get here? What do you get here? CS2. Okay. So along with the first 2 similarities you got there in homologous series, in properties of homologous series, they have same functional group and similar reactions. And between any 2 adjacent member, there is a difference CS2. Okay. This is third. And the fourth difference I say, the molecules getting bigger, right? Down the group, the molecules getting bigger. When the molecules get bigger with increasing carbon number, then their melting, boiling will also what? Increase. Bigger the molecules, greater the intermolecular forces, greater the intermolecular forces. So with increasing size of the molecules, the melting boiling will, what would happen? Increase. So just a minute, please. Just one more minute. Where's the note? I hear. Okay. I don't have the note. I didn't open the note. So this is up to, okay. Time is finished. Our course puts in the next class. I'm going. Everybody clear? And next day is a test. Everybody? Thank you.